Okay, so today we're going to get started on chapter 7. And so in chapter 7, kind of like in chapter 5, we're going to be making comparisons of parts of polygons, mostly just triangles. So we're not always going to have equations, or we should say we're not going to have the same lengths all around, kind of like we had in prior chapters. So to start things off, we have something called a ratio. You've seen ratios before. It's simply a comparison of two or more quantities. So some examples, student to teacher ratio. So hypothetically, let's say you're at a school where the student to teacher ratio is 10 to 1, or a speed limit, 65 miles for every 1 hour. Another ratio, 1 to 3. So that's one symbol that we can see with ratios, that colon, 1 to 3. You could also literally just write 6 to 7. That's another one. So we're comparing two different quantities in each of these examples. Now, you could compare 3 or 4 or 100 different quantities. Typically, we call that thing an extended ratio. Like if you were going to look at the number of students compared to the number of teachers in a room compared to the number of windows, that could give you all kinds of different combinations there. We're typically just going to see comparisons of two quantities, but you can have all kinds of combinations. Now, if you have an equation with ratios, we call that a proportion. So a proportion is simply an equation of ratios. So one example, 5 to 2 is the same as 3 is to x. Notice we could also, and in fact, the most common way that we are going to express ratios is with a fraction. So you can use a fraction, you can use the word 2, or you can use that colon symbol. So here I've got the ratio 5 to 2 is equal to the ratio 3 to x. Now, this is something from algebra you should remember how to solve. We always solve these proportions by cross multiplying. So if you had to solve this one, you would multiply both sides by x and 2. So you'd get 5x equals 6 and then divide by 5. So just keep that in mind. We are going to solve a lot of proportions in this chapter. So that's basically all we need to know from 7.1. How does this apply to geometry? Well, it's going to tell us things about corresponding sides. So we're going to get into this concept of similarity. So we're going to say that two polygons are similar if all corresponding angles are congruent, and then all corresponding side lengths are proportional. So this is different than congruent polygons. Congruent polygons were the same shape and the same size. Similar polygons are the same shape, but they could be a different size. So for example, I've got triangle ABC and triangle FDE. They've got all of the arcs in the right spots. Angle A congruent to F, B congruent to D, C congruent to E. And then let's look at all those side lengths. So if I compare, say, the biggest side length of AC or ABC, that'd be 15. The biggest side length of the other triangle, that'd be 15 over 5. Well, let's see, let's reduce that. 15 over 5, that's the same as 3 over 1. But that's the same ratio you get if you do 12 over 4, the medium length to the medium length. That reduces 3 to 1. And then the smallest length to the smallest length, 9 to 3, also reduces 3 to 1. That tells us that all of these side lengths are proportional, since you have an equation of ratio. So I'll have the same ratio, or they all reduce to the same exact fraction. So we would say that those two triangles are similar. Now, that number we got, 3 to 1, it's kind of an important number. We call that thing the scale factor. So scale factor, that's the ratio of corresponding side lengths when you know that you have similar polygons. That's an important number because it basically tells us the relative size of two similar polygons. So if I have another set of polygons and the scale factor is, say, 1 to 4, that means that one of my polygons is a quarter of the size of the other one, and the other polygon is 4 times as big as the other one. So that scale factor is really important. And in fact, we're probably going to be doing a project at the end of this chapter where you apply this concept of scale factor. This is something people use all the time in day-to-day life. That's actually going to do it for 7.2. You should be good to go for those questions on Schoology.